From the nation's capital, the Conservative Caucus presents Conservative Roundtable, an in-depth look at today's most important issues.
Welcome to Conservative Roundtable. I'm Howard Phillips, chairman of the Conservative Caucus, which sponsors these broadcasts. We're very privileged to have as our guest Tom Bethell. Tom is a journalist in Washington, D.C., a senior editor of the American Spectator. He was, at one point, Washington editor of Harper's and an editor of the Washington Monthly, both of which magazines have seen their better days, by the way. He has written for many other magazines, including Fortune, the New York Times Magazine, and the Atlantic Monthly. He has been a columnist for the Los Angeles Herald-Examiner and the late-lamented Washington Star. He also is a media fellow at the Hoover Institution in Stanford. He's written several books, including The Noblest Triumph, Property and Prosperity Through the Ages, very good book, The Politically Incorrect Guide to Science. The writer and high-tech analyst George Gilder has said that Tom Bethell commands the most eloquent prose in American journalism. In 1988, a collection of his journalism was published under the title The Electric Windmill. Tom Wolfe, who usually dresses in white suits, said that the book, quote, establishes Tom Bethell as one of our most brilliant essayists. His new book on Einstein's theory of relativity is written for the benefit of laymen, includes no math, and argues that the facts of physics can be more simply explained without relativity theory. In plain language, it advances the views of Peter Beckman, a great man, now deceased, who wrote Einstein +2 and for years taught at the University of Colorado. A graduate of Oxford University, class of '62, where Mr. Bethell studied philosophy, physiology, and psychology. Tom came to the U.S. in 1962. He's married to Donna Fitzpatrick Bethell, chairman of the board of Christendom College, an excellent institution from which my youngest son graduated. This is an interesting book, and believe it or not, this is going to be an interesting program. Even if you're not a physicist and don't know anything about science, because I'm in that category. But let me begin by asking you, Tom, Stephen Hawking once wrote that, quote, if one wanted to live longer, one should keep flying to the east so that the plane's speed is added to the Earth's rotation. What does that mean?
Well, you have to go back a bit. First of all, I'm promoting or discussing in this book the theories and the ideas about relativity of Peter Beckman, who was a good friend of mine. He wrote an excellent newsletter called Access to Energy.
I read it regularly.
He came to this country from Czechoslovakia in the 60s, and he was very eminent and I think really brilliant scholar in math and science and physics, and I think he actually taught electrical engineering. Anyway, I remember he told me once that I asked him what he was working on, because we used to talk quite a lot, and he said that he was working on a revision of relativity, that the whole thing could be explained without relativity theory, the physical anomalies that had led Einstein to propose the theory of relativity, the special theory, in 1905. And so I thought, well, that's very interesting. And because I hadn't heard anyone talk about that, and I knew Peter was very smart. So I said, okay, well, I will, you know, he'd written this book called Einstein +2. That came out a few years later. And it was actually quite difficult to understand because it was filled with math and stuff. So I said, well, why don't you do a plain language version of this? And he said, well, I thought about it, but I thought it would be taken more seriously by the physicists if it was in the language of mathematical physics. So I said, well, I'll do it. I'll write a plain language. And he said, that'd be great. I'll help you. Then, unfortunately, a few years later, he died quite quickly at the age of 68. But meanwhile, he had converted somebody else to his ideas, somebody called Howard Hayden, who taught physics at the University of Colorado. University of Connecticut, sorry. And anyway, so Hayden was able to help me. And I did really need some help, because when you work on these things, you think you sort of understand it, but then when you actually get to writing it, you find a lot of things you don't understand. So Howard Hayden helped me, and then finally I was able to get this book finished just recently. And in fact, this is the first program or, television or even radio that I've done discussing it.
Thank you for being here.
Thank you. Anyway, so what we need to, in order to understand something about relativity, I mean, it is difficult, I guess, to understand, although I think if you were to read my book, you could kind of get the point.
Let me stop you here.
All right.
For our audience, explain as succinctly and simply as you can what is Einstein's theory of relativity, special and or general.
All right. Very simply, although the idea is impossible really to accept, it's the idea that the movement of the observer affects space and time. Reality becomes sort of observer dependent, and this is what Beckman could never understand.
And you talk in the book about a man looking at another fellow's watch.
Oh yeah, if you and I have right now, if you and I have our watches on, we've got identical watches, both absolutely going at the same rate, and I move, I see your watch slow down. That's to say, and my watch doesn't change; it's still going at the same rate. And you see my watch slow down, and you think, well, how can just the movement of one person affect the rate of the passage of time with somebody else who is not moving? And this is right at the heart of what relativity is trying to say. And what Einstein postulated, he assumed, he didn't demonstrate, he assumed that the speed of light has to be a constant at all times, irrespective of the movement of the observer. So if the observer, if I move towards that light bulb there, then the space and time in the reference frame that is not moving has to adjust so that one divided by the other, space divided by time, always gives you the same quotient, always gives you the same c, the speed of light. So essentially, time has to adjust and space has to adjust in order to keep the speed of light a constant. Why does the speed of light have to be a constant? Because Einstein postulated that. So it leads us into these absolutely absurd and impossible things to believe, including the fact that space and time is dependent upon what the observer does. And this is really totally unacceptable. This was unacceptable to Peter Beckman. He said, I just can't believe that. There has to be a simpler way of looking at this. And this is what he worked out in his book, In Einstein Plus Two. So I can go into a little bit more. There's a famous experiment by the Michelson-Morley experiment. Did you ever hear about that when you were at Harvard?
No, I did not.
All right. Well, anyway, there was this guy called Albert Michelson who in the 1870s, 1880s, tried to detect what is called the ether. Now, the idea of the ether, sound waves have to have a medium that they travel in, and that is air. So there was obvious that light also was a waveform. There are wavelengths of light, different wavelengths. So there had to be a medium in which light rays travel. And that was called the ether. And so it was assumed that the whole of space, that ether filled the whole of space uniformly. And the Earth, because it's going around the sun, is moving through this ether all the time in its orbit around the sun, you see. So he figured that you would be able to detect the Earth's movement through this ether. As it were, if you're in a car, you can stick your finger out of the car window and feel a wind. So there should be an ether wind. So he set up this experiment, which was very refined. It was done in Cleveland in 1887 with somebody else called Morley, Michelson and Morley. And they tried to detect the presence of this ether, and they could not detect it. This became one of the most, perplexing developments in physics in the late 19th century. That was 1887. So then Einstein came along a few years later, in 1905, with a special theory of relativity which accounted for this outcome. And in the course of the various things that Einstein assumed in his special theory, one was that the speed of light has to be a constant at all times, and this would account for why Michelson had been unable to detect this effect, you see.
Mm-hmm. So what is it, 186,000 miles per second?
Well, That's the speed of light. But the Earth, you know, because the Earth moves in this quite large orbit around the sun, it's going at quite a high speed through this ether, and you ought to be able to detect it, presumably, but they couldn't. So Beckman then comes up. There's one great idea that Beckman had, which is the sort of a central point about his rival alternative theory, and that is that the ether does exist. Einstein then said the ether didn't exist. He said we will assume from now on the ether does not exist. Beckman says, yes, it does exist, but it's not quite what you think it is. It's not some uniform substance that fills the whole of space. It is, in fact, the local gravitational field. All celestial bodies, including the Earth, the Sun, have their own gravitational field, which is moving along. And in the case of the Earth, the gravitational field, obviously, is moving along with the Earth. So you stick your finger out of the car window to feel the wind. You don't feel the wind because the wind is moving along with you. But, this gets to the question that you asked, the Earth is also rotating all the time. You know, once every 24 hours it goes around. And it rotates within its own gravitational field, which means that there should be this ether wind that Michelson tried to find, but it would be much smaller because the rotational velocity of the Earth is much, much less than the orbital velocity as it goes around the Sun.
What about the theory that if you are in outer space for a period of time, you can come back younger?
Well, they have all of these, yeah, they have these experiments. The problem with, one of the problems with Einstein's theory is that it's filled with these so-called thought experiments. And one is this twin experiment where, you know, you've got two twins of the equal age. One goes off and comes back and is younger. No such experiment has ever been done.
You don't believe that's true?
No, I do not believe it's true, nor did Peter Beckman. And for one thing, you cannot look at this from the perspective of special relativity, because for special relativity to apply, it has to be uniform speed in a straight line, no acceleration, no deceleration, and the twin has to come around and come back again. And so that screws everything up from the point of view of, and you have to look at it from a much more complicated perspective of general relativity.
We have to take a break here, Tom. When we come back, we're going to, among other things, discuss the political implications of relativity and relativism. Stay with us. We'll be back shortly with Tom Bethell.
My name is Walter Jones. I represent the 3rd Congressional District in North Carolina, the home of Camp Lejeune Marine Base. And I'm pleased to be here today to encourage the American people to remember that their voices need to be heard by those of us in Washington, D.C., both the House side and the Senate side, that there are too many issues facing this country. There'll be a new president in 2009, and we need to let our voices be heard. From immigration issues to terrorism to the fact that this country's debt, we owe China over $900 billion. But I want those people that might be seeing this interview to know that we, the American people, with the help of God, we can change the direction of this nation. Just like the American people did on the issue of amnesty when it was before the Senate. They made telephone calls, they sent faxes, emails, and they wrote letters, and they said to the Senate, do not pass this amnesty bill, and it was killed.
Welcome back. I'm Howard Phillips, Chairman of the Conservative Caucus, and we're delighted to have as our guest author Tom Bethell, who has written a book which I urge you to read, Questioning Einstein, Is Relativity Necessary? Now that may sound pretty esoteric and far-fetched and beyond your normal interest, but this book is very well written. It will whet your appetite, and you're bound to learn something if you read it. And it's an easy read. It reads very well. You don't have to be a math expert or a physicist to read the book. It's a good book. It's very well written. Now, one of the things that has interested you, Tom, is the connection between relativity and relativism. And you have indicated that, quote, what makes relativity so hard to understand is that we are expected to believe that the external world is affected by the observer. Space and time are supposedly observer-dependent. And we touched on this before. According to relativity, you and I have identical watches, and we are standing next to one another or each other. When I move, your watch slows down as I see it, but you observe no change in your own watch. At the same time, you observe my watch to slow down, but you observe no change in your own watch. Understanding why my motion affects time in your reference frame is the heart of special relativity. And you go on. And it hasn't been observed by experiment. But
has not been.
Has not been.
Yeah.
Now, relativism says if it's morally okay for you to do something, then no one can say that you are wrong. So morality also becomes observer-dependent in relativism, just as the material world does in relativity. Why don't you expand on those thoughts?
Well, yes, I mean, this is first of all, the connection between relativity and relativism. A lot of people are interested in that. When they hear that you've written a book on that, they sort of assume that you're going to be talking about that. In fact, I don't really have this in the book because Peter Beckman urged me not to put it in because he was afraid that if the establishment, physicists and so on read this, they would think that this was my real motive for writing it, that I was objecting to the decline of morals or something like that, and therefore taking it out on relativity. So I didn't put it in the book, but, as I say, there's no particular reason why we shouldn't discuss it here. And, and it did strike me that there is this striking similarity that in physics, in relativity, the world is, as it were, observer-dependent. You move and you affect space and time. They somehow change, which is just incredibly difficult to believe. And that is what, in fact, Peter Beckman said, no, I can't believe that. There has to be some other way. And then you get the same, and then you realize that you have the same thing in relativism, where morals are somehow, each person can have his own morals, because we hear this said all the time now, if it feels right for you, then do it. If it's okay for you, then it's okay. And so this is basically the same sort of idea. And notice also that the whole thing happened also in quantum mechanics, which came along at about the same time as relativity. A little bit later, 10 or 15 or 20 years later, it was argued by Niels Bohr and others that a particle's position could not be completely determined because in the act of observing it, you affect what you are observing. So again, reality becomes observer-dependent. Now, it's interesting that Einstein himself, this was later on by the 1930s, he did not really go along with this. He said, no, you're just taking what was measured with fairly primitive instruments and coming to conclusions. Maybe that maybe there's some other way of looking at this. And he tried to hold out against it. And in fact, I think Einstein in his later years became really more conservative, more politically conservative in a way. He had a radical period in his youth when he came up with the special theory of relativity, and then he tried to go against it, against quantum mechanics. And as an eminent physicist at Caltech, Carver Mead, who was more on Einstein's side on this quantum mechanics thing, said, if they could put him down, you know, as famous as he was, they could push him aside. Think what they could do to you, you know, and this is the world that we still live in. So funnily enough, I think I thought the great irony would ultimately be if it was shown that Einstein were wrong about relativity, but right about quantum mechanics. And everyone has assumed that it's the other way around, you see. So I kind of enjoyed that thought.
Tom, when you were a student at Oxford, what was the focus of your studies?
Well, it was scientific to a large degree. I mean, I did philosophy, physiology, and psychology. And psychology was of the rats running in mazes kind of psychology. And we also did a lot of philosophy of science, where you learned what was the meaning of a science, what is really a real scientific theory. And you had Karl Popper, and you studied all of that stuff. So it was actually quite useful.
Where did you learn how to write?
When I came to America later on,
Really?
Yeah. Oh, yeah. Just by doing journalism, writing stuff in articles in newspapers and local newspapers and so on, and then when you get to see what you have written in the paper in the next day or the next week, you can see, oh no, that's terrible. You can see how. It's only by getting published, I think, that you can really see how things can be improved.
It's amazing how the English language or the use of it has deteriorated. Even the New York Times. You cannot open the New York Times without seeing grammatical, compositional errors. And my favorite is the double possessive, a friend of Bill's. You're either Bill's friend or a friend of Bill. You're not a friend of Bill's.
Of course, the thing is with the Times, you know, they're losing a lot of, all of the media, the regular print media are losing people, and they don't have nearly as many editors as they used to have. And I mean, there are far more serious problems with the New York Times than that.
I mean, the quality has really gone downhill.
Yes.
And let me talk a little bit about how I learned, as poorly as I am a writer. I went to a great public school, the Boston Latin School in Boston, started in 1635. I had a magnificent Class 6 teacher, 7th grade, Class 6, Mr. Mahan, and he talked to us about the importance culturally, politically, and otherwise of preserving the integrity of the English language. And one of the reasons I edited a lot of direct mail copy, and I drive people nuts because I'm always editing and crossing things out and changing it. I do this as a matter of loyalty to that 7th grade teacher.
Yes.
Who really taught me to love and respect the English language.
Yes.
And then when I was a freshman in college, I had a graduate student who taught English composition. We all had to turn in 1,000 words every Monday morning at 8 a.m. And that's where I learned what a horrible writer I was. He ruthlessly edited everything that I turned in.
Right.
And I eventually learned how to write a simple sentence.
Writers much more nowadays have to do that. They have to edit themselves because these publishing houses basically don't have editors, not the way they used to have.
Everybody needs an editor.
Yes.
No matter how good you are, you're going to make mistakes.
And you know what the key to editing, I think, and I was thinking about this when I was writing this book, is make it shorter. If you can make it shorter, far too many of these books are just way too long, and articles are too long. If you can shorten it down, and I got it down to 200 pages.
Terse and compact. We have to take a break, and we'll be back with Tom Bethell after the messages. Again, I urge you to read Questioning Einstein, Is Relativity Necessary? It's a great read. Stay with us.
This is Duncan Hunter, Congressman in San Diego, and you know, I built that border fence that we use in San Diego right now, the double fence, and I wrote the law that takes the fence some 700 plus miles across Arizona, New Mexico, Texas, and California. And I just want to urge everyone, stand strong on border control. And don't open the door to amnesty, because if you open the door to amnesty, we're going to see massive waves of folks coming into this country illegally, and you'll have lots of people coming in illegally expecting to catch the next amnesty and the next amnesty. We need border control, and we need to enforce existing laws. Hang in there.
Thanks for joining us on Conservative Roundtable. We've been privileged to have as our guest Tom Bethell, author of Questioning Einstein: Is Relativity Necessary? A Must-Read. If you're interested in the issues we discussed on Roundtable, check out our website, conservativeusa.org. Fax us your name and address free of charge. We'll send you literature, 703-281-4108. Tom, what closing comments do you have?
First of all, I got interested in this partly because of what Peter Beckman told me, but also because, like many people, I think almost everybody, you ever try to read these easy Einstein books about relativity, it becomes impossible to understand what's going on at a certain point. You suddenly find yourself totally out of your depth. And it's not because of the math of special relativity is actually quite easy. It's high school algebra, no more than that. And so I thought, well, I've got to write this in a way that makes it simple for people to understand, and I hope I have done that. The general consensus of feeling is that Einstein's special relativity is true and has been proven over and over again, and general relativity, which is much more complicated, involves gravity. Well, that maybe need a little bit of correction and change.
30 seconds.
But I come to a different conclusion. I can come to the conclusion that special relativity is definitely wrong. It has been shown to be wrong. There is an east-west difference in the speed of light, which gets to your original question. General relativity, on the other hand, does seem to give the right answers, but by a complicated method, and if you use Beckman's assumption, you can get there without relativity.
Tom, next time you're here, be sure to wear your Baileys ring. Thanks for watching us.